Okay, this is the P4 paper from June 2021. It's question number 7. And as we can see, this is a vectors question. And in particular, when we get down to this part here, it's going to be solving geometric problems in 3 dimensions. So let's have a look at the question. It says we've got a line R, which is defined by being 1 minus 10 minus 9 plus lambda lots of 4, 4, 2. And then it asks me various different questions about it. Well, let's just remind ourselves of what that means. I wouldn't necessarily put this straight away as part of my answer, but by the time I get to parts B and part C, I understand that I do need a diagram, so having drawn this in the first instance isn't necessarily that bad a thing. So what we've got is some point here, 1 minus 10 minus 9, and then my line passes through that point and is parallel to the vector 4, 4, 2 here. That's a very crude diagram, but pretty much explains both of those 2 parts of my equation. Right, it says given that OA is the unit vector parallel to L. Okay, so OA, obviously comes out from the origin then, is going to be this vector here, which is parallel to this line here, but is also a unit vector. Okay, well if it's parallel to it and a unit vector, that's easy enough to work out then. So OA, the first thing I want to do is to work out what the length or modulus of 4, 4, 2 would be. So that's going to be the square root of 4 squared plus 4 squared plus 2 squared, and that works out to be 6, which is always an indicator that I'm going on the right sort of lines here. So the unit vector, the thing that I want, the unit vector parallel to our line is equal to a sixth of 4, 4, 2. And then a sixth of 4, 4, 2, you can actually tidy that up to be 2/3, 2/3, 1/3. Okay, so part A, not too bad. Part B then says, point X lies on L, okay, so it's on the line somewhere, and it lies on L so that it's closest to the origin. Okay, so X can be anywhere along here, but it's not those ones, because what I also want, if it's the closest one, is that what it's going to mean then is it's actually going to be there where it's perpendicular to the original line. So OX is going to be there. What have I got to do? I've got to find the coordinates of OX. Okay, well, if I've got to find the coordinates of OX, there are 2 things that I know about it. First of all, I know that X is on the line itself. So if X is on the line, one of the things that we can say is that it will fit into this criteria here. So if X is on the line, I could start off by saying OX is going to be equal to, and what was it? It was 1 minus 10, 9, plus lambda lots of 4, 2. So OX is going to be 1 minus 10 minus 9 plus lambda lots of 4, 4, 2, or in other words, is going to be 1 plus 4 lambda minus 10 plus 4 lambda and minus 9 plus 2 lambda. The other thing we can say about OX is if it's perpendicular to the line there, it's perpendicular to 4, 4, 2, then the dot product is going to be equal to 0. So let's just explain that to the examiner. If A and B are perpendicular, then A dot B equals 0. I don't think you necessarily need to write that in. I'm just trying to make it clear to the examiner what I'm doing here. So 1 plus 4 lambda minus 10 plus 4 lambda and minus 9 plus 2 lambda, that dotted with 4, 4, 2 is going to equal to 0. So if that's true, 4 lots of 1 plus 4 lambda plus 4 lots of minus 10 plus 4 lambda plus 2 lots of minus 9 plus 2 lambda is equal to 0. Multiply that all out and tidy it up, we get 36 lambda minus 54 equals 0, which means that lambda works out to be equal to 1.5. If lambda is equal to 1.5, we can sub that back in here. So we'll actually get that OX is equal to, do it slowly, 1 plus 4 lots of 1.5 minus 10 plus 4 lots of 1.5 and minus 9 plus 2 lots of 1.5, which then works out to be 7 minus 4 minus 6. Let's just go back and see. They wanted the coordinates this time, so just be careful. They actually want the coordinates. So coordinates are 7 minus 4 minus 6. Just be careful to make sure you're answering the questions that they've asked us for. Okay, what does the last part say? So the last part says the points O, X and A form a triangle. Okay, right, let's put that in then. Let's make my line a bit bigger just so we can see this. We're talking about then this triangle here. Okay, that's the triangle that I'm interested in, OXA. Can I find the exact area of the triangle OXA? This is why it's really important to draw this diagram out, guys, because then this makes it really straightforward as far as I'm concerned. Remember, we already know that the length of OA is 1. OA is the unit vector. So if I want to work out the area of this triangle, I'm just going to do half base times height using those two values there. So really what I need to do is to work out the modulus of OX. That's straightforward. Okay, so part C. If I want to work out the modulus of OX, then that's just going to be the square root of 7 squared plus minus 4 squared plus minus 6 squared. That works out to be square root of 101. It's not an exact value, that's absolutely fine. So then area of triangle is equal to half base times height is equal to a half root 101 multiplied by 1. It's a unit length, so that's 1 there, so it just works out to be square root of 1 over 1 over 2. Okay.